Welcome to chapter 2.1 about quadratic equations. So a little review to start. The quadratic formula, hopefully you know, but it's x equals negative b plus or minus square root b squared minus 4 times a times c, and everything is over 2a. Now please be careful whenever you're using this formula. You have to make sure that the equation equals 0. Once it equals 0, then you can find your corresponding a, b, and c value. So let's consider this first example. Consider the quadratic equation x squared equals 5 minus 3x. Well, first thing I notice is that the equation does not equal 0, so I have to make it equal 0. I'm going to do my work over here. So normally it was x squared equals 5 minus 3x. I'm going to decide to move everything to the left side, only because I like to have a positive a value. So this is the problem I'm working with. I now want to do parts A, B, and C. Part A, use the quadratic formula to find the roots of the equation. Well, it's nice that it has it equal 0, and I have the quadratic formula right here. So let's take a moment and plug in. Let's have a little more room. So, part A, quadratic formula. X would equal negative b plus or minus square root b squared minus 4 times a times c all over 2 times 1. So when you simplify, I'm getting x equals negative 3 plus or minus square root of 29 over 2. Just like always, if you are able to simplify under that square root, please do so. It will make your life easier as we keep going with these problems. Okay, so that's part A. Part B says compute the product of the roots. So we're going to take this part A and just multiply the roots. Notice there is 2 roots because one answer will add root 29, the other answer will subtract root 29. So when I do the product, it will look like this. Negative 3 plus root 29 over 2. I'm going to do parentheses here. We'll multiply by negative 3 minus root 29 over 2. Okay, so those 2 roots being multiplied together will give me the product. Notice on the top, I'll be foiling. So when you FOIL, you'll get 9 plus 3 root 29 minus 3 root 29, and then root 29 times negative root 29 is actually just a negative 29. The denominator you are multiplying, so make sure you multiply 2 times 2 to get 4. Now what's really nice here, these actually cancel out, they're the same thing. I can simplify that numerator. I get 9 minus 29, so really you have negative 20 divided by 4. So really when I do the product, it simplifies pretty nicely to just 5. Okay, I'm going to make this all a little smaller. But that's what we did. We took the product, we did some foiling, and then we simplified. Part C is very similar, but we're computing the sums of the roots. So for part C, the sum, we're going to have negative 3 plus root 29, and we're going to add it to negative 3 minus root 29. Notice we have common denominators, so I can combine like terms. Notice this is a plus root 29 and a negative root 29, so those go away. And I'm left with negative 6 over 2, which leaves me with the sum as negative 3. The reason we do that is now we have our little, what do you notice? Well, we took this original equation right here, found its roots, found the product of the roots and the sum of the roots. Hopefully you notice that -5 is actually in the original equation. The -3 is in the normal equation, but the sign switches. So something to note here, I'll put it even in red because it's super important. The C value is the product of the roots. Right here. This value, the product, is the C value in the original equation. The B value. Some people might want to say the B value equals the negative of the sum of products. Sum of roots. Other people like to look at it as -B equals the sum of the roots. Both ways work perfectly. It's up to you. But notice the sum right here is the opposite of the B value in the equation. Please be aware with all of this, this only works when your A value equals 1. So notice because of this 1 right here, I'm able to notice this pattern with the B and the C values. This is very nice when we're given a problem, such like this next one. We don't have as much math we need to do. We're going to first find the product and the sum of the roots of this quadratic equation. Now you could do, like above, part A, part B, part C, but now we have a pattern. The only thing we have to worry about is that this 2 is there. It's not a 1. Okay, this pattern only works when it's 1. So my first step I'm going to do down here, I'm going to take the equation. It's 2x squared plus 6x minus 7 equals 0. I'm going to divide everything by 2 on both sides. The reason I do that is now I'll get that coefficient of 1. I get 1x squared. I'm going to get a positive 3x. I will get a little fraction here. That's okay. But this is now the equation I'm going to look at. Okay, it has that 1 in front, so I'm good to go. Looking at it, the product, remember, the C value equals the product. So the C value in this case is -7/2, right here. The B value equals the negative sum of the products. Notice the value is +3, so the sum would be -3. I think that's much easier than actually solving each part. You can use this little pattern. Again, remember this needs to be a 1 in front. You can also go the opposite way. I can actually give you the roots and you can find the quadratic equation. You'll do the same product, sum of roots, and that will give you the parts of your quadratic equation. So let's start here. So if I want to find C, C is the product, so that's going to be R1 times R2. My root 1 times root 2. So that looks like 1 plus root 5 over 4 times 1 minus root 5 over 4. Make sure you FOIL on the top. Get 1 plus root 5 minus root 5 minus 5. On the bottom, you are still multiplying, so please make sure you put 16. You're multiplying 4 and 4. Like before, it's pretty nice. These cancel out. So you're left with -4 over 16. Please simplify, and you get -1/4. So that would be your C value in your equation. Let's do the B value. I'm going to put the negative B value equals root 1 plus root 2. And this is your preference. If you prefer to look at it as the sum with a negative sign in front, that works too. So with that negative sign, I'm going to show that I'm adding my first root with my second root. I have my common denominators, which is perfect. So when I combine the top, notice these cancel. And you're left with a negative sign still and a 2 over 4. That common denominator stays when you're adding. So I'm getting negative 1/2 as my B value. Okay, notice I already have the negative of the B, so this I can plug straight into my equation. I'm going to give myself a little room. And now let's plug into my quadratic equation. It's going to look like x squared. My B value is negative 1/2 x. And my C value is negative 1/4, and it equals 0. Now, normally this would be okay, but in most of the problems we give you, we're asking for integer coefficients. Which means no fractions, no decimals. So if we ask for that, what you would do is multiply everything by the least common denominator. So in this case, it would be 4. When you do all this multiplication to each term, you're eliminating the fractions. So you'll end up with 4x squared minus 2x minus 1 equals 0. This would be your final answer with integer coefficients. Okay, just a couple more. Let's use the quadratic formula to solve these next two problems. It already equals 0, so I can just get going and plug in my A, my B, and my C. So part A, x would equal negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Simplify. I am getting 0. Square root of 0 over 8. This is pretty nice because the square root of 0 is just 0, so it goes away. So x in this case would be 3 over 2. Notice this is just one root. When you add 0 or you subtract 0, you'll get the same answer. So we're going to talk about these kind of special cases here. So make sure you note that this is just one root versus above there was 2 roots. Working on part B now, same thing, it already equals 0, so we're in good shape. X squared plus x plus 2 equals 0. So quadratic formula, plug in. I'm getting negative 1 plus or minus square root. I'm now getting a negative 7 on the bottom. So right away, this should look a little familiar to you. When you have a negative under the square root, this would be called an imaginary. Okay, if you try to take the square root of a negative on your calculator, you would get either error, no solution. It's not possible to take a square root of a negative. So when that happens, this problem would say you have no real roots. So now we've covered every case. The first examples had 2 roots. We now had an example with 1 root. And now we have an example with no real roots. Let me show you what that is visually. So here, graph A has 1 x-intercept. 1 x-intercept, 1 root. This point right here. Figure B has no x-intercepts, no real roots, because look at it, never crosses this line. It doesn't have an x-intercept to cross. The last one has 2 x-intercepts and it has 2 real roots. Here and here is where it crosses the x-axis. Okay, so we just covered all 3 of these cases. Here you can now see it visually. 1 point crosses, no point crosses, or 2 points. It's nice to see on your calculator, so I'm going to show you the buttons to press. If you have questions about these, please ask in class. But here is how you graph 1C. So the buttons to press on your calculator. You're going to press second, trace, which is on the top bar. You're going to press the button that says 0. And again, like before, we did this in class already, you have your left, right bounds, where you arrow over and show where the intercepts would be. Okay, so we're doing it for graph 1C, which is y equals x squared plus 3x minus 5. Take a moment, please type that in your calculator. Give it a try. Hopefully you took a moment, tried this out. These were the 2 values I got, which kind of look familiar. If I'm looking at this graph right here, again, we're just confirming, I could see it's a little past -4 and a little bit more than +1. I definitely could see that. Let's say your calculator was being crazy one day and you want to actually do it by hand and confirm. It's actually not that bad. You're going to take the original equation and use quadratic formula. So it looked like x equals -3 plus or minus 3 squared minus 4. Again, we're working on 1C. That's where I'm getting these numbers. I got square root of 29. Notice because there's that plus minus, there will be 2 answers. So how I like to show it is one of the answers will be x equals -3 plus root 29 over 2. And the other one would be x equals -3 minus root 29 over 2. Make sure you fully simplify the numerator, then divide by 2. When I do that, get 1.19. On the bottom, completely simplify the numerator, then divide by 2. Oops, I'm running out of room. Sorry about that, guys. I get -4.19, which, if we confirm, is the same answers we actually got from our calculator. And same points from the graph. So just many ways to look at these roots, many ways to check your answers, and many ways to use a quick little formula. If you have questions, feel free to ask them in class. Otherwise, good luck on your homework assignment.